In the previous lecture, I explained how shift registers work in general, what the principle of operation of a shift register is. And there's a lot of shift register integrated circuits out in the market. In this lecture, I'm going to show you how to use this device here, which is a shift register. It's a very popular device, very inexpensive as well, and plentiful. You can find it on eBay for just a few dollars. The device provides an 8-bit storage plus 1 for the overflow. The first thing that you need to do whenever you have a device like that you want to integrate with your circuit is to have a look at its datasheet. So the datasheet for this particular device is here. There's a lot of very useful information that you can find. For example, very early in the beginning, so in the features, we know that this is an 8-bit serial device and it shifts out the bits so you can use them in a parallel mode, as we're going to do in this lecture. You can connect it to input voltages and power it from 2 volts to 6 volts. So it's got a wide range of operational voltages. It consumes very little current, 8 microamps maximum, and a lot of other useful information here. But most important for us at this point in time is to scroll down and have a look at the pinout of this device. So here it is in section 6. You can see that this is a device that we have. It also comes in different packages, but the one that we have here is a DIP package with 16 pins. You can see that the 8 bits output are distributed in one side, so the first 7 in one side of the device, and there's another one here. So QA, QB, QC, D, E, F, G, and H, these are the 8 parallel output pins. As far as the input pin is concerned, is this pin right here. So pin number 14, marked as SCR, that stands for serial, and that's the pin that will connect to our Arduino in order to send it bits from the Arduino and write them onto the LEDs. You can see the information here as well. So there's a ground pin, we've got output enable, we've got the QA to QH pins, those here, which constitute the output. There's also another pin here called QH with a little mark on its side, which is pin 9, and we call that the overflow pin. This is a very useful pin to know about if you plan to have gadgets that drive more than 8 LEDs or relays or other devices. And pin number 9, the overflow pin, allows you to daisy chain multiple shift registers together. And I'm going to show you how to do that in the second demonstration, where we'll use 2 shift registers to drive 16 LEDs. In this lecture, I'm going to show you this circuit. Let's zoom out for a moment. I'm going to show you how to work with the shift register using this example circuit. So what we've got here is a representation of our shift register. So here are the 8 output bits from QA to QH. We connect those to the LEDs that we want to drive via a 220 ohm current limiting resistor. And then those are connected to the 5 volts pin on the Arduino. Notice that the QH, pin number 9, the overflow bit, we leave that unconnected. That's what the X means. And in the next lecture, I'll show you what to do with this pin if you want to support more than 8, that is, more than 8 LEDs for the output. On the other side of the shift register, we've got the data, clock, and latch pins. Now these are very important pins. The data pin, which is number 14 on the shift register, it will be used by the Arduino to send the bit values to the shift register. So imagine the bits flow from the Arduino into the shift register through this jumper wire into pin 14 of the shift register, which is this pin right here. Next we have the clock pin, which is 11, and I'll be connecting that to pin number 10 on the Arduino. So here is clock, pin 11 right here. We use the clock to synchronize the transmission of the bits from the Arduino to the shift register. Every time the clock essentially ticks, one bit will be sent through the data wire into the shift register. And finally, we've got the latch pin here. This is number 12 on the shift register, and I'm connecting that to pin number 9 on the Arduino. To use a latch, there are two things to remember. We bring the latch pin to low while the bits are shifting from the Arduino into the shift register in order to prevent devices that are connected to the output, in this case our LEDs, from reading transient values. So the idea here is that for as long as the Arduino is transmitting data to the 595 shift register, we want to isolate the outputs from what is happening inside the chip, from the changes that are happening inside the chip. And to signify that to the chip, that is to signify the fact that we are changing the memory inside the chip, we bring pin 12, the latch pin, down to low. So we'll bring that to low. Once we have completed making all the changes that we want in the shift register, then we'll bring pin 12 to high, and that will signify to the shift register that it's okay now to update the output pins with the new values that were inserted into the shift register. So two things to remember here: as you're about to send new bits into the shift register, bring the latch pin to low, and once you finish updating the shift register, bring it back to high in order for the changes to take effect. So that is pretty simple, I believe. Thanks for watching. If you'd like to learn more, check out my Arduino Step-by-Step Getting Started and Arduino Step-by-Step Getting Serious courses on the Tech Explorations School. There, I help you develop basic and more advanced Arduino skills, including how to write your own programs, how to use all sorts of sensors and actuators, and how to create your own gadgets. You may also be interested in my project courses, where you get deep into the development of wheeled robots, remote-controlled cars, and drones. Please use the coupon code in the description below this video to get a YouTube exclusive discount to my courses. See you there.